Hello, welcome back once again. So today my voice is not so clear because of some sort of chest infection, or let us say even cold also. But that doesn't prevent me from preparing lectures, of course. So I found a very good problem. Let us not say very good, but addressing it would be beneficial to a lot of people. So this is a problem. So we have a 10-meter long ladder. So the length from here to here will be 10 meters. So let me say it is L equal to 10 meters. Or if I use some symbols here, let us say this is X and this is Y. So it should be equal to X, Y. And its weight is 200 newtons. So weight which acts from the very middle will be 200 newton. So I have written as W is equal to 200 newton. So since this weight acts exactly at the middle, so what I can write here is I can write the full length as L, full length of the ladder as L, and the half length as L by 2. So from to here it is L by 2, and from here also it is L by 2 up to this point, L by 2. And if I name this point as somewhat like a Z, so I write a Z in a crossed manner. Students often ask me its reason, but I haven't told them. So I have told some of them from previous batches, but not this batch. So it will be, so if I write the symbols here, it will be YZ equal to ZX is equal to L by 2. That's equal to 10 by 2 equal to 5 meters. 5 meters. And now we have this angle of inclination as a 60 degree as shown here. Angle formed by the ladder with the horizontal. And it says that one end leaning against a smooth wall. So this wall is smooth. Smooth means that it does not apply any friction. It does not apply any friction. And the other end, the ground which is not smooth. So that means here there will be frictional force to uphold the ladder. Now we have to find the reaction on the wall, reaction of the wall. So reaction force given by the wall and the total force due to the ground here. So let's first realize that since the wall is smooth, it will not have any frictional force. So whether we are raising the ladder, raising like this, or whether the ladder is slipping like this, the wall will not exert any frictional force. So that means it is just the reaction force that exerts. So that's why let us name it as R. So this is the reaction force given by the wall. So I name it as RW. So RW is the reaction force given by the wall. So it is RW. And then here on the ground, what happens is here it is not smooth. So that means there will be frictional force. There will be frictional force. So as this ladder tries to slip like this, the frictional force will be acting in this direction. It will be acting in this direction here. This is frictional force, and that's what holds the ladder. Also, there will be a force of reaction from the ground, which will be like this. So this is the reaction force applied by the ground. So let's name it as RG, frictional force, and then we'll have the resultant force. So now we'll have the resultant force given by the action of this and this in a combined manner. So if I draw this vector somewhere else, it should be like this. So it should be RG, it should be RG, it should be frictional force F, and then the resultant force due to both of them should be somewhat like this. So this is the resultant force. So this will be FRES, which we have to find. And we also require the reaction force of the wall as well. So let's do the mathematics here. So what we can do here first is, so since the body is in equilibrium, the whole thing is about equilibrium. So since the body is in equilibrium, So we must have total upward force on the body should be equal to total downward force. Total upward force on the body should be equal to total downward force. So from here, what we can know is the total downward force here is just this weight. So this is downward force is a weight. So weight should be equal to the total upward force. The upward force is the reaction given by the ground. So that's equal to Rg, and that's equal to weight equal to 200. So it's equal to 200 Newton. So weight is 200 and Rg is also 200. On the other hand, we have the total force to the right. Total force to the right should be equal to the total force to the left. So here we have no force to the left, but here we have, so we must have frictional force is equal to Rw. So frictional force and Rw are equal to each other. Still, we don't know the value yet, but they are equal to each other. So now, what we need to do is, since the body is in equilibrium, we can take any point as the fulcrum. So fulcrum is the point at rest. So we can take any point as the fulcrum. So if I take this point as fulcrum, Ff and Rg cannot rotate this body, because in order to rotate a body, there should be some sort of distance from the line of action of the force with the fulcrum. But these forces pass directly through the fulcrum, so they will not have any action. But this force and this force will do something. So this force will try to move this thing clockwise. If I take this as fulcrum, this force will try to move it clockwise, and in the same case we have got this force will be trying to move it anti-clockwise. So this force clockwise and this force anti-clockwise. So if we taking moments about, so taking moments about, moments or torque, I can say moments about point y, what I must have is the torque or moment due to this thing. So it's equal to 200 into this distance, so distance from here to here, and this distance will be equal to this into cos of 60. So this distance will be equal to this distance into cos of 60. So it will be equal to into yz cos of 60. This will be clockwise torque, clockwise moment. And about Rw, it will be equal to Rw. So this thing will be moving this thing anti-clockwise. So it should be, the distance will be Rw into this distance from here to here or here to here. And this distance will be equal to this into sine of 60. So this distance is equal to this whole distance into sine of 60. So it should be Rw into, it is xy, so into will be in small letters, into xy sine of 60 degree. So one is 200 yz cos 60 and another is Rw into xy sine 60. So if I do calculations here, I can easily find this value. So it will be, this is L by 2, this is L. So 200 into yz is L by 2 into 0.5 should be equal to Rw into L into, this will be 0.866. So this whole calculation will give the value of Rw as, so we can cancel this L and L. So it will be, so it is 100 into 0.5, 50 divided 0.866 equal to, so this Rw comes to be equal to 57.77 Newton. So Rw, the reaction of the wall, is equal to 57.7 Newton. Now, if we have to calculate the total force due to the ground, which is this force here, so since Rw equal to this much, I can say that this Ff is also equal to Rw. from here. So what I can do is, so therefore frictional force is also equal to 57.7 Newton. Now Rg is equal to 200, which is already there. So we have this force resultant is equal to, so therefore total force due to ground, force due to ground which is given by force resultant is equal to root of, it is Rg square plus Ff square. So which will be equal to Rg is equal to weight equal to 200. So it is a 200 square plus this Ff is 57.7 then square. So that will be equal to, so it is 208 Newton approximately. So it's 0.1, but I have done it as 208. So now since we have to find the total force, we need to find the angle also made by this resultant with the ground. So the angle will be equal to, given by tan of alpha will be equal to this by this, so it's equal to Rg by Ff, and Rg is equal to, it is 200 Newton and Ff is equal to 57.7. so this will ultimately give me alpha is equal to, so let's do it here. So I have a shift tan inverse in the bracket, is 200 divided 57.7, so equal to, it is 73.9 degree. So that means the resultant of these forces will form an angle of 73.9 degree with the horizontal. So today I have recorded this video in spite of my ill health, because we just had the results of our students. It is of A level, Cambridge A level of major exams, and I was motivated with the results. That I'm not in a good health, but the results made me motivated. So others might celebrate by cutting cakes or sweets. So I thought to celebrate by recording one more video. So I think that's what I am. I have done this a few times, and this time also it's the repetition of the same. Thank you.